And before we start with the questions, I would ask you guys to maybe give us a short introduction about yourself. I think Björn doesn't need to introduce anyone. But the rest of us, maybe we start from left to right.
Okay. Hi, I'm Nicola. I work here at Commercetools, and I'm basically the front-end JavaScript developer, and we do use GraphQL.
Hi, I'm Muki. I'm from Gute Frage, German's biggest Q&A platform, and we are currently launching our GraphQL internally. So we have it in production, but not yet used in our front end.
My name is Michael. I'm working at Bayerischer Rundfunk. I'm replacing Sami today in this QA. I'm mostly a front-end developer, but also had some back-end experience also for GraphQL.
All right, awesome. So I see you guys added a lot of questions, and we have quite some upvotes. So I think I'll start with the most upvoted one, which is I think a classical question when it comes to GraphQL. How do you solve the so-called N+1 select problem? In other words, how do you prevent the consumer from executing unexpectedly expensive queries? So I think anybody of you can just take it off. If you prefer.
I think I just had a talk with you about this. As he already said that you're doing like the deep checks in the queries. I think it's also important to give weight to specific query fields, because some queries are more expensive as other ones. Yeah, maybe you could talk more about it.
Maybe before we talk more, can somebody quickly explain what an N+1 problem is? Maybe that's not clear to everybody. I don't know.
Well, sure. I mean, the typical case, if you basically request something, this has basically a collection and would result in something. So the typical thing, maybe I try to explain it differently via an example, is you have sort of friends and or people and their contacts, right? And you fetch multiple people, and you want to basically fetch also their top 5 contacts, right? This is typically a scenario for an N+1 thing, where for every person you fetch, you would individually need to fetch his request. So it's basically N+1, right? And this is resides usually in scalability problems, right? Because it's dependent on the number of people you sort of select, and the higher that gets, the more expensive and the more queries you basically do. Regarding what we do in GraphQL for Xing 1, it's like it's an odd answer. I keep repeating myself, but Sangria is already doing most of the magic there. So in terms of execution, basically, we for those kind of scenarios that might be happening, we almost always internally use something which is called a deferred. So in Sangria, you can basically define the resolver result as either immediate, future, so something that might be fired off asynchronously and eventually will come back, and something like a deferred, which is just basically saying, okay, at some point I want to have here the result of this particular ID, but it's not fired off yet. So Sangria internally fetches those kind of things together and is able to optimize those kind of things, which in the end happens. I mean, in terms of a hierarchy thing, in most of the cases, Sangria is able to optimize this once per sort of level or depth level in a query. So if you have select basically a user node and another user node and all of their friends, it would basically figure out how to get the first top level user nodes somehow together, and also all of their friends together in one request. Yes.
Maybe I think what is basically also is most important is that you have a sort of caching layer. So for example, for Facebook, if you query a friend and friend of friends, you are querying like 100 friends of friends, but you query the same friend in a lot of different fields. So if you are just caching the request on the end of the GraphQL, and the most important, most expensive things are the database requests in most cases. If you just are caching this function, you just have to do this once and flatten the request. So I think that's basically the first step and most important for this problem to witness the question.
Yeah, I mean, what we do on top of that is basically we analyze queries, right? We assign cost to complex fields and expensive fields, and you have a budget as a caller, and when this budget is exceeded, we basically reject queries. We also limit the depth of queries, so basically we don't allow arbitrarily deep queries. This is what we do right now. What we will do next year is basically don't allow arbitrary queries at all in production. So for instance, at register time or build time of our apps, basically the queries are replaced with a query identifier, and we just allow basically known queries in production, which also takes this security aspect a little bit, or solves this security aspect a little bit more than what we do right now.
I can just add a couple of things about this. So actually, I talked about it last time about this problem, how we had this problem, and how we solved it. And basically, we were fetching categories, and then we were requesting children of the categories, plus the number of products for the for that category. So it wasn't even a bigger problem because we were making even more requests. And then Oleg implemented this in GraphQL, and obviously using Sangria. And basically at the end we were making one request. And internally he was using what you mentioned also, this complexity. What's it called? Basically, it was calculating the complexity of the query based on how many children of the categories you were requesting to like prevent the query just to explode.
Yeah.
So, yeah. That's also another point for Sangria, I guess. Yeah.
That's awesome.
Yeah, we're looking with the same issue as well at Gute Frage when you fetch the question of the user and then his answers, and then from the user for the answers you get pretty nested stuff as well. We haven't yet implemented complexity, but we are trying to test these deferred resolvers because most of our internal APIs always work on a bunch, so you can ask for a set of IDs. So give me a question for the set of IDs. So we hope that these deferred resolvers can batch simply everything into one microservice request. So in the end, well, it may be a big list, but that's all. In the end, it's just a single request to one service.
This is also how we do it.
Yeah.
Okay, awesome, thank you. So the next question, okay, this is not changed, is about microservices. So how can you use GraphQL in the microservice architecture? I think we have one special candidate who's most suited for that one.
Okay, I can start. So we at Gute Frage we use Finagle, the full stack from Finagle, so all services and the clients, and we're using Thrift for communication between the services. So we don't use HTTP. Thrift is I think it's was developed by Facebook. Now it's an Apache project, which is basically a service IDL. You describe your service and you generate code in your preferred language. In our case, it's Scala, and you publish these APIs, and then your clients can or your services can create a client for this API. And our GraphQL service basically uses all these clients and does the requests against these Thrift APIs. So we get all the Finagle infrastructure, which Björn already mentioned. You get retries for free, you get timeout filters, you get circuit breakers, you get automatic discovery, you get monitoring admin interfaces. This is a pretty whole stack. It's very badly documented, in my opinion. So we started, there's the Finagle Docs project. We started at Gute Frage, so everything we learned, we tried to put in open source project. And so, yeah, So finagle the hard part to put this all together as a documentation. And then GraphQL actually was the easy part to just query all the services where you have to, for Scala, you have to figure out the implementation details because Sangria uses Scala features, Twitter has their own implementation. But in the end, it works everything pretty smoothly because for us, Twitter finagle does all the heavy lifting and we can mainly focus on the business logic.
Basically true for us as well. I mean, from a high level, basically we also have this microservice-like setup. Proxy is just an aggregator of multiple services, APIs. In our case, it's HTTP, which we use, and JSON there as a communication protocol, but it can be anything else. Right? It could be, Finagle also supports Memcache there, right? And also Thrift is something we might look up at some point in that regard.
How do you do the service discovery? So you have DNS names or?
Very poorly, right? So this is very much in progress right now because we are switching from basically VMs to Kubernetes right now and to a Docker-based environment. This is an ongoing project, and a lot of those kind of things basically change with Kubernetes. In the good old days, we just have hard-coded DNS names there, which are load balanced by a central load balancer. And this is how we used to do things right now. Obviously, with Kubernetes, this is different because you still load balance against central APIs, but the whole process, how those mapping between those kind of parts of the system work is much more dynamic now.
In our case, at Bayerischer Rundfunk, we are more just developing a new thing out of a new. We have a completely new database layer for our applications. So, as GraphQL is like a good solver for the problem if you have a swarm of microservices and you want to combine it. It's a little bit other thing if you are just developing a new application where you want just the benefit that you have like the one endpoint for your app or web app. So I can't really tell much about it. I think, and I'm not really a backend developer by us from our team, but I think we really started with GraphQL because it's like a cool new thing, and also started developing a lot of back-end microservices in GraphQL, and then merging the GraphQL schemas together to a newer GraphQL. But I can't really tell you that this is a great idea because you're losing a lot of application layer in this. Maybe it's the best if you start a new project to just put everything together in one monolith-like GraphQL server, but be able to split the business logic in like packages which can be put in microservices afterwards. If you are not dependent on different programming languages. So most times if you start a new project, you can stick maybe on one programming language, or maybe you also, if you have the case that you have to implement something that has to be written in Go because it's very computation intensive, you could choose its microservice and then your proxy. But
from our side, we also have something similar. So we have for the front-end team like a backend server, which works basically like a proxy. So it basically connects to different APIs, and that's the main thing about it. And the good thing about front-end developers is that we can just connect to one API, and then it doesn't matter where the data comes from, basically.
Yeah.
APIs you're connecting all internally, or are there also third-party APIs?
For now, mostly internal APIs. Yeah.
Because my question would have been, what do you do with external schema changes? So if your external API changes,
So actually, asked Oleg this question before, and he also said that the backend that Commercetools has is a monolith still, so we don't have really microservices baked into the core of the platform. But he said that GraphQL fits very well. Like we're saying, it's hard to do it, and it most certainly is. But it also is if we don't use GraphQL, right? To stitch multiple microservices together into one and merge like their like schemas into one. So it's hard in any way. And he also said there is still work to be done in that space. We see a lot of libraries popping up now around the term called schema stitching. He said he doesn't really like the term, so maybe there will be a new term soon. I don't know. But he also said that the type system that GraphQL brings helps detect the conflicts that you will have between those schemas. Right? Because one microservice might use a type that is the same or has the same name as another microservice. And as we don't have namespaces, right? So what do we do? But the good thing is that we have a type system that helps with detecting these collisions before they happen, because we can like statically analyze it. So just some input from Oleg. So funny, he's not here, everybody's talking about him. All right, next question. How do you solve caching? And there's multiple answers to that, so because we have multiple layers, so I don't know, pick any of the layers.
We don't do caching. But actually we wanted to try, the Apollo engine came out recently, and they say they support caching also on a field level. I guess for us, for our API, it makes sense only on specific parts, because usually you want to get up-to-date data, but for things like the user, you can also cache it. So we still have to experiment a bit how it works. But in general, we don't do much caching at the moment.
We do neither. So our main traffic comes from logged out users, and we have a vanish cache which caches the whole produced HTML, and this is also good enough for most of our use cases. So we had a short period, a few days, where vanish wasn't working and nobody noticed. So our main traffic was completely hitting our infrastructure, and we saw a slightly increase in our response times, but that was it. So for us, caching is not really relevant because it reduces latency for our users, which is good, but it's not mission critical. So yeah, we don't care. And that's a good thing because caching is hard and you do a lot of things wrong. And we have vanish and it has way too much logic, and we have quite a few big bugs due to this. So if you can go without caching, go without caching. This would be my advice from hard feelings and experiences.
And sorrow.
And sorrow and pain. So yeah.
Yeah, we don't cache in GraphQL at all at the moment. Right? It's not that we're not thinking about it, but we haven't come to a satisfying conclusion yet. I particularly don't really like the optics approach, pretty much, because it would involve putting yet another thing in front of our platform, which we very likely won't do. What seems more reasonable to me is basically caching basically towards the inside, right? So basically caching the service responses that we get internally there somehow in Memcache, which is basically in the end basically caching on a resolver level. So basically caching the API implications there, which then would eliminate some of the things we've been done so far, because in order to do that properly, you have to request everything and cache it there. So that basically would increase the traffic in our data center internally, which we've just basically optimized out with all of the nice selection set forwardings there. So we are unsure about that, but it's the likely thing that we are going to do there. Other than that, we aggressively cache in the services itself. And so when there's an opportunity to optimize speed to get them to really low millisecond response times, we do that usually in the service. Right? And benefit, of course, then on the higher calling layers of that. It's usually easier to do because you have basically you have ID lookups or something, which can be fairly easily cached, rather the more abstract infrastructure GraphQL, which is definitely more involved in terms of caching.
And we are also caching a little bit, but I think too little. So I think you have for the GraphQL like this black box, and there's like the output and the input, and the output arise mostly from queries that are really big and user specific. So you have like authentication token and the HTTP request and so. So I think there is no really chance to cache it. Just the HTTP request with some nice things. At the input, so like for the REST requests, they are a good point. But I think also very good is, but the best point would be inside of the GraphQL, where the functions from the resolvers are stitched together. Because as I said before, with the caching, if you have you don't have to implement a fancy invalidation caching if something changes on the database. Just a short TTL caching would be enough to just batch the most n+1 problems, I think. And there we still just have a little bit problems, I think. So I'm not just not the backend developer from our team, but I think they are just having problems because of the auto-generated resolvers to put this kind of logic in there. But I think this is a very important point if you're start developing GraphQL endpoint and not likely using Xing sort of stuff.
Is anyone doing client-side caching with global IDs? Somehow?
We're using Relay, which supports caching out of the box. I think Apollo client does it also, but I think you have to, it's a little bit more complicated to configure. So I think, but also Apollo client and Relay have like a client-side store, as a proper React, or I think in all cases some kind of Redux store. There are a lot of things are cached, so it does a lot of performance improvement.
Okay. Nicola, maybe you want to say about the Apollo client?
Yeah, I mean, I guess it's also like Relay, so it has an internal store, normalizes the data that comes from GraphQL, and it's like cached. So if you, and you can then specify like a policy to fetch. So you can say, I always want to read from the cache first, but still make a network request, so the cache gets then updated, or only try to load from the cache. But that really depends how you want to, I guess, build your UI. If you want to do like optimistic UI, so, or if you just want to have always the latest data, then it's up to you, I guess. But I guess Apollo gives you the chance to do that.
And as Björn and I talked earlier, it really depends on the use case as well. Like if you're, as you said, New York Times, right? Your article that you like posted 1 week ago, it won't change. So you can easily cache it and then it doesn't matter if it's GraphQL or something else. But if you're working with product data or like users and stuff like that, messages, right, it will change all the time. So there is no use in caching that. So I don't know, or responses to questions, I don't know, stuff like that. Questions might be edited, answers might be edited, all that kind of stuff. Yeah.
Yeah, we even have another problem on top of that basically a user can actively decide what kind of settings he allows others to see on a person-to-person level. So depending on who is looking at the data, he might see different things, which makes the whole caching scenario so horribly hard that it's almost always a better idea to just do the caching at the lowest level that knows about all of this privacy stuff and not do it at the higher level, because you have no sane way to figure that out without an explosion of sort of data there. Right? Because you would otherwise have to cache all permutations somehow, which doesn't simply doesn't work.
maybe one more thing to clarify. I think so. The caching that you guys mentioned in the resolver is on a per request basis, also in Sangria, I guess, right?
Mm-hmm.
And that's the same for the JavaScript library. So if you use data loader from Facebook, it's basically the same. It allows you to do the caching. We also use that, and it's also always on a per request basis. So it's like all different kinds of caching everywhere. You just have to, I don't know, wrap your head around it. Do the quick wins. Yeah.
Maybe also, Oleg also mentioned basically he would rather do caching on a lower level, so not on the GraphQL level. So I don't know if you're like, if your resolver fetches data from a database or from Elasticsearch or whatever, you can try to cache those requests basically.
Yeah, from our experience, I can recommend profiling and tracing and fixing your slow requests. So we have Zipkin, and we see one service call or one call to our currently proxy call can end up in 100 service calls where in each service are 10 or 20 database calls, but everything is concurrently and in parallel, and you can actually see then your requests are only 10 milliseconds and all run in parallel, so it takes 12 milliseconds maybe because one started a bit later, and then it's fine. So you try to figure out what is actually slow before trying to cache something that is slow, because in the end it's slow. So before you have it cached, it will be slow for some users, so better try making it fast before caching your slow responses.
Which is one more great thing about GraphQL, because it makes the tracing super easy. So it's very easy to identify which field was actually slow to resolve. So that's, I think, really awesome about GraphQL, and like helps with this whole scenario. Okay, next question. Which programming language and database technology are you using, and how well does it work with GraphQL?
All of them. Elasticsearch, MySQL, Redis, Memcached. I think we have Cassandra somewhere as well. React? No, not yet. No, hopefully.
Yeah, I mean, in terms of databases, we have MySQL, we have Redis, we have Memcache, we have Cassandra, we have React. I think that's it. In terms of programming languages, we have PHP, we've got Ruby, we've got JavaScript in the front end. We have Elixir. We have Erlang, yes, and we have Scala and Java and Objective-C and Kotlin and Swift. That's it. Not yet. Not yet. I think they're more in the flow camp.
We're down to Scala and TypeScript now, so pretty happy about that.
Database things I think we use mainly for Bibliothek, MongoDB and Elasticsearch. Postgres is used for our new BR24 project. We have I think we have a Couchbase anywhere, but it's more deprecated thing. For programming language, we mostly use Node, JavaScript, so mostly EMCA stage 0, and I didn't deprecate Java, so that's, the cool people from us are using mostly Go and JavaScript, but we are also having a lot of other programming languages, but just tiny projects. I think the main ones are JavaScript.
But are you accessing all these databases directly from your GraphQL service? Because I think we both hide it behind some other services and HTTP or PostgreSQL.
For GraphQL, we are using PostgreSQL, which is a direct access to the database. So you're just writing. I don't know how it's exactly. I think Max or on this team, that they are a little complex.
The thing is,
when we set it up, it had to go really fast because we had lots of time pressure at the moment. So one of my colleagues who did that took a decision and he said, okay, we are gonna go the easy way, which was PostgreSQL, which works on top of PostgreSQL. And the thing is, if you use that, everything will be auto-generated, the whole schema, I think, and also the resolvers. So it's really fast to set up. But nowadays, that was about 6 months ago, I think. And it's really getting back at us now because we don't have the control anymore about any of these parts, which results in problems as soon as you want to do anything on top of that. And yeah.
I already looked a little bit in NPM for node implementations. There are a lot of these kind of things out there. For example, for MongoDB, you also could build such things, but I would just run because of the lack of application layer.
Yeah, also the caching. I think it's really troublesome to implement any of that if you have this kind of architecture. I mean, that's what we are running into right now. We have some of our requests result in lots of queries, and we just can't cache it, and we can't build a cache without replacing the whole backend. So,
I just think if you're building a good GraphQL, it shouldn't be a matter of the database you're using, because you're just using any programming language, and there you're using the database client. So maybe if there is no database client in the programming language you want to use, you maybe should use the programming language for your GraphQL client that supports the database. But it's not a question of the database for GraphQL.
Yeah, GraphQL is just like a thin API layer on top, and then you have your data layer below, and in there, like that could be services, that could be like on the same server, whatever, but the logic of accessing these databases is in the data layer. So GraphQL doesn't really notice that. You just have to abstract your way, I guess. Yeah. But any like bad experiences that you could share, like please don't use this combination of database and language and GraphQL, or would you say it doesn't really matter?
We enjoy Sangria and Scala.
I mean, one thing to have to be aware is that the feature set in the implementations is different. Right? So just from what we saw is basically that you get the most bang for the buck in Sangria. A little less basically with different features in Ruby and in Elixir. Apollo is, I think, nowadays also a good choice, but when we looked at it, it was also completely different. It was pretty basic. You could basically build up from IEL the schema and then have to connect it to JavaScript functions. But all the other questions around is like, how do you prevent those n+1 kind of things? How do you analyze queries? Nothing was basically there. So this is something you have to be aware of in terms of selecting the effort you personally need to put into the project in order to make the infrastructure work. And for us, it was definitely one important fact to search something where we don't have to answer those kind of questions, because probably our version would have been worse than is already out there and better tested. That's more the line of thinking in that regard.
We could recommend typed languages for GraphQL because you have a typed spec or typed schema, and using it with a typed language reduces a lot of the headaches you can have. So.
Also, if you want to refactor it, right? Good IDE support. And we basically ripped out the whole JavaScript library. Was a pull request with I don't know, 1,500 deletions and 2,000 additions, something like that. And we put it into the staging environment. One acceptance test failed. Okay, that was fixed. Afterwards, it directly went into production. I have a hard time, really. I've worked in dynamic languages, but I have a hard time imagining this being possible in JavaScript or Ruby. I think it's just more trustworthy.
Yeah.
For what it does.
All right. Next question. Yeah. you'll know why. Okay. How did you deal with the Facebook's patent license decisions for their tools, and what were your thoughts during development?
What the fuck was my thought? I mean, it caused some stir, definitely, on our side, because obviously we weren't unsure what is going to happen there. But in the end, everybody I talked to, also Oleg, who has got a good connection directly to Facebook, to the guys there, were like, okay, this is going to be worked on. Just wait, there will be a solution, and I think the overall solution they went for is pretty cool. So I mean, the specification, and this was, I mean, the problem was that the specification was basically cut into a patent, right? So which it isn't anymore. So right now it's basically in this Open Web Foundation agreement. What is it? Organization model, and you just have to look what else is there, and the DOM model of the browser is also there. So that gives you some impression in what territory you are there nowadays with the specification. And the rest is basically just a plain MIT license with a patent grant, right, which was also missing at the time, which has been added. So from our side, this kind of thing is fixed.
Stop worrying about licenses now.
Yes.
Finally. Okay. Next question, which I think is a really interesting one. How do you solve authentication and authorization in your GraphQL server?
I think GraphQL is mostly just HTTP post request. So there you, the query itself is in the body of the HTTP request, but you can just put the information in the body, which kind of data you want to get. But you also can put some information in the header, like authentication token. So in the backend, you can then get this token and use it in a middleware. So middlewares are a great thing for GraphQL servers. With this, you can, for example, put the logic in a middleware to transform the token in like a user info. And with this, you just have to put like this token there and can resolve, can write resolvers that just can get the user info as context.
Yeah. Okay. We have two sets. So we have API tokens, API keys. So we deliver different schemas to different API tokens. This gives us the flexibility to add new fields, for example, only for internal clients. We have business partner that see a different schema, so we prevent them from using fields they shouldn't see and shouldn't use, which saves us a lot of time from explaining, hey, I see this field, why can't I access it? I get an authentication error, like, yeah, it's only internally, so, yeah, but I want to use it, so we save us all these troubles with our clients because not exposing fields to them. And then we have using Sangria's field tags on a by field authorization, and we check that in the middleware. We have a request context factory as well in the beginning, so we build our request context, where the authentication information is posted if available, where our user has a role, and then we check on a field you can specify the roles at the moment, that's the only thing, and then we validate and we throw exceptions on the fields that aren't available with the current authentication information. So we use those both strategies for authentication authorization.
Yeah, authentication, I think it's easy, so you just check the guest header. In our specific case, for this, it's a GraphQL proxy backend that we maintain, we don't deal much with authorization because we're making API requests to different services, which they will handle then. So we just obviously get a valid auth token to connect to those APIs with the proper scopes for the user and so on. But that's everything we do, and then we just forward a request, and then that service then takes care of the validation of fields and whatever. I think the recommendation also from Facebook is to not do those things in GraphQL. If you can, you do it on the database layer. Yeah, so try to keep it clean of those logic.
We're also just doing authorization basically, and it's pretty much what you normally do with all sorts of APIs. Is either token-based or cookie-based. We do this for the OAuth stuff for our mobile apps and cookie elaborate cookie scheme for basically the web part. We don't do any authorization logic at all in the GraphQL proxy. This is done basically in the lower level, in the service. What we do is basically we have in all APIs we have an additional field called the RID, which is the requester ID, which is basically the ID of the authenticated users, which is passed on to the underlying API. And all sorts of authorization happens there, because we think it's business logic somehow, which has to be implemented on the level of the service.
I just want to add that we are just not doing the login process itself, so the authentication process over GraphQL. It's just if you're authenticated, you get like this token, and the backend can see if you are authenticated, but the authentication itself is not in GraphQL. I also think that this isn't a really good idea because it's not like it could be a mutation, but in all cases you would just warp a security risky function in a GraphQL server that mostly is a microservice. This also could be directly accessed from the client. So you could save this function.
Okay, we have a couple more questions, but it's getting late. So I guess we can do some quick ones. And I'll try to avoid the questions that I added in the beginning. Because they have long answers. So, do you use subscriptions?
No.
Everybody know? No? Okay, that's easy. How many people are on the Xing backend team involved with GraphQL? How big in terms of manpower was the effort to get where you are?
So in the GraphQL project, to understand that.
Yeah.
3 internal, 1 freelancer. That's it.
Doesn't sound much.
No. And we have been working. One of them, internal people, has been doing half-day support for our API infrastructure on top of that. So it's actually a little bit less than that. But it was fairly doable with that.
Okay.
And
Next.
is the freelancer Oleg?
No. No.
The invisible freelancer. All right, next
If
one.
I wouldn't tell you.
Have to investigate.
Do you select only the attributes from the database which are queried in GraphQL query? Or I guess do you just always select the whole record from the database? Question clear? Not clear?
Yeah, it depends if you do. If you have access directly to the database, I guess you can try to just get those fields. I guess like in Mongo, you just do a projection. But if you talk to like API, REST APIs, you get everything, and then just have to map it.
Makes sense. How do you handle file uploads with GraphQL?
And then repeat it.
You don't.
Well, we have to. It is sucky. There are multiple ways to do that. There's the intermediate solution which we have right now, which is basically good old base 64. Right? But there's also a native way, but it involves changing the we haven't come around doing. We will eventually do that, but so far the base64 version with all of the limitations in terms of size and carrying around this huge blob of data works. Obviously, you have to be careful to get that out of the tracing data and the log data. This is also what ended up happening in our monitoring tool. There was this giant line of variable in there. I was like, oh, maybe we should start thinking about filtering that one out. Yeah, exactly. But it works. I mean, it works. There's also, if you ask a little bit around, there's some people also say, just, I mean, GraphQL, for instance, has a dedicated REST API for that and don't have it in the graph, which is also a valid strategy. We wanted to try it out first in the graph, see whether it works, and then fall back to the old way in case we couldn't make it work. And so far, it kind of works within the bounds, right, of base64. And we'll definitely try out the other solution, but nobody has in general complained so far about it. So it's not the nicest solution, but it works kind of.
What's the upper limit for the size of the blobs?
I have to look it up. I don't know off the top of my head. It is constraints.
Okay, next one. Do you serve different schemas based on API keys? And I think we had a partial answer to that.
Yeah, that was my question. So, because I'm
Okay.
currently looking for people who are actually doing the same, because I haven't found anybody else yet, and we figured out that it would be a nice way to reduce the schema based on who is looking at our schema, which is nice if you have business clients.
Meetups does that. So they have they are using it differently for different purposes, but they have sort of a preview version or preview fields in there. And then depending who is asking the server, they basically surface different fields in the schema for testing out things in their side first before they publish that kind of stuff to the public API. We should have a talk. I'm interested in the topic as well.
Bringing people together. All right, do you also use GraphQL to modify data on the server or only to get data? Yes? Yes?
Yeah.
Yes, 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 yes. Okay, we're good. That was easy as well. There was another one. Would you implement business logic in the resolver function or an extra layer? That is the extra layer, I guess. All right. One that we haven't really talked about in the panel yet, which I actually would make the last one. How do you monitor your server without HTTP status codes? And I think everybody can answer that, and then
Just thinking.
Not yet. So we have the thrift, the finagle monitoring. So we see which client calls fail, so we kind of know which parts of the queries go wrong. But as we are not using it yet for our first feature, we haven't yet spent a lot of time implementing monitoring, but we will definitely do so. And we use Grafana and OpenTSDB, so we probably publish metrics there at the first step, and we'll probably do something like we described on a query name basis, so we actually see what queries are fired and what are the response times and what fails. But we'll have to, first we have to do something actually where get traffic.
Well, the question is what you want to use it for. I mean, I think I would treat alerting, for instance, separately, which is definitely one question that needs to be addressed, which we haven't right now. There's some interesting ideas around from Twitter, by the way, who are also using Sangria. They're basically tracking the rate of partial query failures. Basically use that as basically when the rate of partial errors goes up within sort of a certain time period, then they notify or alert other portions of the platform. Obviously, status codes don't work anymore. Since we still have them, at least for this queries we don't execute, right? We can at least figure out that maybe some client is trying to do some unauthorized queries, those kind of things. That still works within the old bounds of the system. But for everything else, you need to be a little bit creative. I think it's doable. We're also doing, I mean, we're using basically Grafana and Graphite. We're likely going to try out Prometheus or Influx because we would very much like to have a tagged matrix somehow. But other than that, it's basically just figuring out the metric and basically creating an alert on top of that.
I think we are having a little bit problems with this because a few weeks after the launch of the Mediathek, we had a little problem with too much load after our change in the client, and we had to look into our Kubernetes cluster load to just identify if it's on the database or like the GraphQL service itself. So yeah, I don't think that I could tell you.
Do you think it's actually harder to do it with GraphQL?
I think it's the question before was like, where do you put your business logic, and our monitoring is where our business logic is. So if a service fails, and probably the GraphQL service fails, so we get the alerting where the actual error is. So we see GraphQL having problems, and yeah, it's nice, but where's the problem? So we try to put our monitoring where our business logic is. And that's the current way in our REST API as well, because the errors bubble up. So we started at the root.
Yeah, so for us in the core platform, we use InfluxDB and Prometheus, and we have Grafana for showing the nice dashboards. Specifically for GraphQL, obviously we're using Gria, so we have like slow logs, those features. And I think Oleg also built some custom matrix for specific queries on top. Just to track also specific things like, I guess, also complexity and all these kind of things. In the backend, in the GraphQL server that we use for the front end, it's much more simpler. We just use Apollo Engine, so that comes automatically with all those tracking, basically. And I think that's good enough for our case.
Right. Then, thanks everybody. Thanks to you guys. I hope this was fun for everybody, and I hope to see you all next time. Bye-bye.